All right, written response number 7, and we're right back to our inscribed figures. I know you guys love these questions. Anyway, so this one is saying that if we've got a semicircle, oh, that's terrible, but you get the idea. So this is 10, that's 10, and this is negative 10 over here. We're going to inscribe, okay, a rectangle in there. The coordinates of this point right here will be x comma y. Okay. However, the piece of information that you don't have here, that you really do need, okay, is that the equation of that semicircle, okay, would be x squared plus y squared is equal to 100. It's basically just an adaptation of the Pythagorean theorem. Obviously, to get a semicircle, I'd have to restrict the range here. But anyway, that's the equation right there. And so what we're looking for here is the values. We're going to maximize the area here. So this distance here is x, and so this distance here is y. Okay, so the area of our rectangle will be 2x times y. I almost forgot to write the 2 in there, despite the fact that I was just marking that off here. I want this to be in terms of just one variable, so I'm likely going to get rid of the y. So y will equal, now I was going to do plus or minus the square root, but in this case here, we're just talking about the top half of the circle here, so I don't really need that. I just need the bottom, just the top half, not the bottom half. So I'm just going to leave it as the positive square root of 100 minus x squared. And so we get 2 times x times the square root of 100 minus x squared. Okay, so now we've got the equation for the, or the expression for the area in terms of just one variable. And so now I can take the derivative of that, and it's going to require the product rule. That's not a big deal here. So the derivative of 2x is just 2 times 100 minus x squared plus 2x times the derivative of our radical function here, which is going to end up being 1/2 100 minus x squared to the negative 1/2 times negative 2x, okay, because of the chain rule here. So 2 root 100 minus x squared. Don't really have to do anything to that first term, but here a few things are going to happen. Those 2's will cancel. Still got that 2 right there. There's a negative there, and then there's 2x's, so this becomes negative x squared over square root of 100 minus x squared. Okay, so there's our derivative. Now, I'm going to set this equal to 0, okay, because we're going to maximize this, which means I'm going to bring this over. Now, just work with me on this one. I'm going to bring this over, which essentially I can put an equal sign in between those two, and then I'm going to cross multiply. Now, that is going to get me 2 times 100 minus x squared equals x squared. Okay, so 200 minus 2x squared is equal to x squared. Oh, shoot. I'm sorry, I totally forgot about that 2 there. Okay, that makes way more sense. I'm sorry about that. I forgot about the 2. There's that. Those two 2's canceled, but that one stayed. I'm going to bring that negative 2x squared over, so this will become, now I know it's getting a little tight to the side of the page, but that's okay. So 200 is going to equal 4x squared. Okay, divide the 200 by 4, and we'll get 50 equals x squared. And so x is equal to, what is that, 5 root 2. Okay? Now, if that's the case, in order to figure out the area, I just got to go back up to this expression right here for the area in terms of x. And area is going to equal 2 times 5 root 2 times the square root of 100 minus 5 root 2 squared. Okay, now, whoops, sorry, that's a little low here. 5 root 2 squared is 50. 100 minus 50 is 50. The square root of 50 is 5 root 2. Times 5 root 2 is 50. Times 2 is 100. And there we go. That's the area. 500, whatever this unit, 100, whatever this unit is, centimeters squared. There you go.